Committed to a cleaner and smarter energy future, our next guest plays her role in helping Australia decarbonise the gas sector by 2050. I'm Mackenzi Oliver, and on this episode of Ready STEM Go, we're chatting to Jess Godfrey about capturing the energy. Welcome, Jess.
Thanks, Mackenzi. It's great to be here.
Thanks for joining us. So, Jess holds a Bachelor of Earth Science at QUT and went on to complete her honours year at Uni Western Australia. Jess was hired by Origin Energy as a graduate geoscientist and over 3 years has worked across many different ventures, from building paleogeographical maps for the Greater MacArthur Basin to providing technical support for the Shoalhaven Pumped Hydropower Plant Expansion Project. Jess is now focused on helping Origin become net carbon neutral, analysing and assessing the impact on the development and deployment of carbon capture and storage, or CCS technologies. As an Origin Foundation champion, Jess has donated her time and skills to help empower young Australians with educational opportunities of equality. So very excited to be speaking with you today, Jess. But before we get into that, have you brought an epic, inspiring, or crazy STEM story or STEM fact with you?
I certainly have, and I think it's going to cover all of your topics, maybe epic and inspiring and a bit crazy.
Awesome.
So this piece of rock that I'm holding is Permian, and that's a period that spans 47 million years, from 298.9 million years ago to 251.9 million years ago. And basically it ended in the largest mass extinction the Earth has ever known. So at that time, a supercontinent was emerging, Pangaea, and due to its incredibly vast size, the Earth was experiencing severe climatic and environmental extremes. And during that time, the east coast of Australia was experiencing an ice age. And that's where this piece of rock is from. It's a glacial-marine facies known as the Snapper Point Formation. And isn't it crazy that I can hold that time period in my hand?
It's crazy that there's, these relics are left behind. Definitely epic, inspiring, and crazy. Diving in, you've already dazzled us with some geoscience stories, but what was it about earth science that really initially made you want to, jump into this role?
Well, a love of mountains and volcanoes and oceans and the beach and exploring and travel. So earth science or geoscience literally has it all. Every landscape and the ability to understand how it formed. It's just fascinating.
That passion that you've got there, very clear, of course. You've now harnessed that with Origin Energy. What are you doing now with Origin as part of the Future Fuels team?
I'm a CCS analyst, so that's a carbon capture and storage analyst in our decarbonisation team within Future Fuels. So our team is helping to decarbonise our operations to align with the Paris Agreement. So if you guys don't know, the aim of the Paris Agreement is to limit emissions to net zero globally in the second half of the century. And to meet our 1.5 degree Celsius global warming target, basically net zero means any emissions have to be balanced by absorbing an equivalent amount of CO2 from the atmosphere. So the geological storage of CO2 is paramount, basically to meet this goal of limiting our global average temperature from the pre-industrial levels. So removing CO2 from the atmosphere will be necessary to compensate for emissions from different sectors in which reaching zero emissions is more difficult. And that's things like aviation, transport, agriculture. Carbon removal can be achieved by a lot of different means, including land-based approaches such as restoring forests and boosting soil uptake of carbon, but there's also technological approaches such as direct air capture and storage, or even mineralization. So what we can do is capture the CO2 from power stations and other CO2 emitting industrial facilities, and using different technologies, we can then store it permanently underground in suitable geological reservoirs.
So it sounds like you're pretty busy saving the planet. So what is your role within the team? You said it was an analyst position. What do you get to do day to day?
Day to day, we analyze and look at different technologies that are available around the world, as well as do a different analysis on what basins are suitable for storage across Australia. Once we've identified these basins, I guess that's where it gets to the more business end versus science end of things. There's a lot of different regulatory requirements that we have to go through with getting things like tenure and approvals in place before we can actually start any projects. And this is just the day-to-day work of making sure that all environmental and water approvals are done, and that we can safely store in the appropriate reservoirs. We have to do years of research to know what the subsurface conditions are and whether or not things are suitable.
And so the subsurface conditions that you're mentioning there, so are the conditions part of the mineralizing process that you mentioned before?
The mineralizing process, depending on the technique you use, can take anywhere from a couple of years. From a company based in Iceland have developed quite a fascinating technique, to 10,000, no, from anywhere from 1,000 to 10,000 years naturally in the subsurface. So what we have to do is store the CO2 in a liquid form. Basically, that means we convert it from a gas into a liquid and put it in its supercritical state. That changes the volume of gas that we have to deal with. Then in order to keep it in that state, we have to inject it at least 800 meters deep in the ground, and that will keep it as a fluid. From that point, once you're that deep in the ground, most of the sandstone or reservoirs that you are targeting do have what's known as saline waters in the pore space. And what these waters do is they help bind the CO2 in place. And over then geological time, that will then mineralize.
Wow. So by being able to convert the carbon into that liquid and injecting it into those 800 meters below the surface reservoirs, so then the rock then is able to, yeah, just essentially capture that.
Basically, yeah. It's quite fascinating. I wish I had a slab to show you, but if you can find a slab of sandstone, anyone can do this as an experiment. If you get a little beaker of water and pour it on your sandstone, what you'll notice is the water will just soak into the rock. And that's basically how, well, if you imagine the water's carbon dioxide, basically how we'll be storing the carbon dioxide. But there are different technologies out there, and our team is all about assessing them. Another method is injecting it into basalt, which is not what you'd typically imagine, which is a volcanic rock. And basically our entire ocean floor is made out of basalt. So there's a lot of land or a lot of places that you could use this technique. And what they do is they mix the CO2 with water, and that can be like a saline water. And what you make then is a type of carbonic acid. When you inject this acid into the basalt rock, it starts to eat away the rock, creating its own pore space. And that's releasing the minerals from the basalt into your carbonic acid mix. And if you know anything about geochemistry, which I'm sure no one does, there's two end members of olivine, which you find in basalt. And they have different elements attributed to them. One is iron and one is calcium. And so when the calcium is released from the olivine in the basalt, it can bind to the CO2 and it will form CaCO2, otherwise known as carbonate rock. And that's a
Whoa.
process that only takes a couple of years.
And that's so exciting. So these are some technologies and things that you've been able to work on as well?
Currently not due to COVID, unfortunately, but it is all technology that we are investigating and researching. There's so much exciting, innovative, new ventures out there in the world that are looking at solving our climate or our CO2 problem. And we're researching them all. We want to make sure we get the right solution for Australia.
Yeah, and it definitely sounds like a very involved process. It must be a pretty big team. Who are some of the different types of professionals that you might be working with?
Sure, I work with other geoscientists, data scientists, engineers, lawyers.
Oh,
We've got commercial. Basically, if you can probably think of it, we probably have someone in our team dedicated to this area of our business.
Wow. So no matter your skill set, if you're interested in helping get Australia to net zero carbon emissions, it sounds like there's a place for you.
Absolutely.
No, that's awesome to hear. So yeah, maybe what's something involved with being a geoscientist that perhaps people wouldn't really expect?
Okay, this is surprising. You get to color in a lot. So
Amazing.
you need a whole lot of good pencils. And when I studied earth science at uni at QUT, I had a lot of labs and tutorials where I spent my whole time drawing and coloring in pretty maps and cross sections and stratigraphic charts. I've even gotten to do it at work.
There you go. So yeah, get busting out those coloring pencils. Um,
Absolutely.
definitely something. Yeah, I don't think I would have expected that.
No
Um,
one does.
we also mentioned a bit before about the Origin, you're as an Origin Foundation champion. Um, so do you want to tell us a bit more about that? What is involved with that role?
As an Origin Foundation champion, basically, the Origin Foundation sits across all of Origin's business, and there are a number of champions or ambassadors to that foundation. So when we have volunteering opportunities arise, we basically talk to our team members and let them know that there's a need for a volunteering person or team to attend. And that's all paid for. So as long as we get manager approval, anyone can volunteer an extraordinary number of days during the work week. And from there, we've got different organizations that we help mostly in education. So one of the most interesting projects that I got to work with the Origin Foundation is the Solar Buddy project, where we go out to schools and teach the kids in a science class how to build a small solar light. We also educate them on what energy poverty is, because it's a really critical thing that a lot of people internationally suffer from. And us in Australia, often our children are unaware of it. That people don't have access to electricity every day, or if they do have access to it, it might just be for 1 or 2 hours, or they don't have lights at night, or air conditioning, or TV, or internet. So these lights give kids that suffer energy poverty the ability to just do their homework at night. And that's an amazing point of change. And it's just a fantastic program to be involved in, to go around to different high schools and primary schools and teach you how to build a solar light, because that's pretty cool, right?
Yeah,
It's a
and what a
fantastic foundation.
yeah, and that project that you mentioned as well, it's like what a good crossover between harnessing your STEM skills for, yeah, creating some positive change.
Absolutely. Absolutely. It's been like really, really rewarding.
So I guess another big part of working at Origin might be the chance to go to some of those big sites. What's your experience of going to some of these sites, and as well as a woman being on site as well?
Wow, the sites are incredible. I've been to Araring Power Station, which is in Newcastle. It's Australia's largest coal-fired power plant. I've had the opportunity to go down to Shoalhaven, which is our pumped hydro power plants. There's 2 of them down there. And I've also been out to our gas fields in Spring Gully and Reedy Creek. And what's really fantastic with working on site with Origin is a very inclusive and diverse workplace. And I think I'm very lucky to work for an organization that's been continually recognized as an employer of choice for gender equality. And I think this has been awarded from the Workplace Gender Equality Agency. And I think because of that, I've had a fantastic time working on site. Saying that though, the industry is still really male dominated, and it's really important for us to get more women involved in STEM and to increase our gender diversity.
Yeah, well, it definitely sounds like it's really promising that it's becoming a more and more inclusive space. So definitely, hopefully, more people are excited to get involved and start, yeah, coming to some of those sites. So yeah, you mentioned one of them, the hydro power plant expansion project. What was some of the work that you got to do there?
Oh, that was a fantastic project. So we did a number of different boreholes or drill holes. The idea was to build the expansion part of the hydro plant underground, so it wouldn't be visible in the landscape. And we obviously wouldn't disturb the wombats, which are just roaming around wild.
Very important. Protect the wombats.
Damn right, because they're very cute. And that's actually where this rock came from.
Hey.
Yeah, it was fascinating. And obviously pumped hydropower is one of the best storage batteries we have in the world for energy. So whilst they're turning Araring into an energy storage battery site, it will have a 700 megawatt battery. Shoalhaven has the ability to store 24 hours, I think, of energy or electricity, and a 700 megawatt battery, which is, I think, 10 times larger than the Adelaide one, will be 4 hours.
Whoa.
So it just gives you a difference in how much energy can be stored naturally in something like water.
Wow. Yeah, I guess people might not know that water can also be a battery.
Yeah, it's fascinating.
Definitely some extra new properties and materials that you get to learn about as a geoscientist then.
Absolutely. Not so much the power itself, because that's more the engineering guys, but the subsurface in how you safely engineer a power station. Absolutely. Are the rocks suitable enough? Are they strong enough? How do you dispose of the ones that you've mined out? All of those sorts of things.
Yeah, definitely. Yeah, so many different things to be involved with there. Well, it's nearly all we have time for today. But before I let you go, if you could go back in time and tell yourself something, tell your younger self a little piece of advice, what's something that you might say?
I think I would tell myself that you can do anything you put your mind to, and to be yourself and be curious.
So, big message of self-empowerment.
Absolutely.
I love it. Well, thank you. So that is all for this episode of Ready STEM Go. Thank you to our listeners. And yes, a big thank you to Jess for joining us today.
Oh, thank you for having me, Mackenzie. It's been wonderful.
No worries. To our listeners, make sure you subscribe to never miss an upcoming episode. And also stay in touch. Join our Facebook group, QUT STEM is for me, to keep up to date with events and resources that you can access. Bye, guys.